Hello, we will go over section 13.3 today, and we're going to start out by looking at the unit circle. Last week we introduced the unit circle and started to look at the specific degree measures as you go around the unit circle. And then we also looked at the coordinates. X is your cosine, Y is your sine as you go around those coordinates around the unit circle. Today we're going to look at the radians. So on our first day we looked at the degrees. So we had our degree measure right here would have been 0. Then we had 30, 45, and 60. And finally at the top of our unit circle that would represent 90 degrees. And there is another way to measure angles, and it's called radians. So there's two different ways to represent an angle. And I also want to make you familiar with a symbol for an angle. A symbol for an angle is called theta. So theta is a Greek letter that is accepted in math as a variable to represent the angle measures. So theta can be in two different modes, I guess. It could be in degrees, or it can be in radians. So degrees we're most familiar with. That's what we've been introduced to as we've come up through our math classes. But today we're going to look at radians. So radians are looking at the arc length of your circle, and that's what we're using to represent the angle measures. So we're using that arc length to do that. And one thing we need to know about a circle is how to find its circumference. The circumference of a circle is going to equal 2 times pi times the radius. And more specifically for our unit circle, it's called a unit circle because its radius is going to be 1. So all the way around that circle, its radius is 1. That's why it's called the unit circle. So its circumference is going to equal 2 times pi times 1, which anything times 1 just is itself. So that's going to equal to 2 pi. So the unit circle has a circumference of 2 pi. That's how many radians go around your circle. So right here we could say this is going to be 0 radians. Also 2 pi radians would be right there. And we're talking about that distance around the circle. So radians measure your angles as these arc lengths. Now let's more specifically talk about these special angle measures as we go through the circle. So our first angle measure comes to this 30 degrees. But what would that be as radians? Well, if we kind of look and break this up into sections, there's one section here for 30 degrees, 2 sections here for 60 degrees, 3 sections. So we got 3 30-degree sections that make up that 90 degrees, and then 3 more over here. And then you've got 3 more down in the third quadrant, and then 3 more. So that's a total of 12 sections. Well, if we take 2 pi and divide it by the 12 sections, the 2 and the 12 will cancel to make a 1 and a 6. So that means that each of those 30-degree sections are going to be pi over 6. So this arc length from here to here represents pi over 6. So the full circle is 2 pi. There's 12 30-degree sections in the circle. So this arc right here is represented by pi over 6. So a little bit of background on where that measurement comes from. Now we can start going around and filling in our radians. And I'm going to use these blank spaces as fraction bars. So this would be pi over 6. So that 30 degrees would be the same as pi over 6 radians. And then we're going to skip 45 for now. So we're going to go 30 would be pi over 6. 60 then is going to be 2 pi over 6 because we're adding a pi over 6. 90 then is 3 pi over 6. And the over here where we'd have the 120, that's going to be 4 pi over 6. And the 150 is going to be 5 pi over 6. And we get to halfway around our circle is going to be 6 pi over 6. And you're probably noticing that some of these fractions can be simplified. We're going to go back and do that once we're done counting up by our pi over 6's. This would be 7 pi over 6. Down to here, again, we're skipping all those 45-degree spots. This would be 8 pi over 6. This would be 9 pi over 6. Oops, is that my degree? Yeah, that's my degree. 9 pi over 6. 10 pi over 6. And 11 pi over 6. Which leaves us then at our last spot would be 12 pi over 6. That's going to be my pi there. 12 pi over 6, which you should know that when you take 12 divided by 6, that's going to equal 2. So there's your full circle, 2 pi radians. So again, the radians are representing these arc lengths, and we can use arcs around a circle to measure these angles inside there. So just another way to measure an angle. So we have degrees, and now we have radians. Now going back, you've probably noticed that a few of these you can simplify, and I'm just going to above try to find some space, or to the side simplify. So 2 and 6 simplify to 1/3. So this is going to be pi over 3. All right, let's see here. That's not very good. So let's take 2 and 6 simplify to 1/3. So that's going to be a pi over 3. So that's what those will simplify to. 3 over 6 simplifies to 1/2. So that's going to be a pi over 2. 4 and 6 make 2/3. So this is going to be 2 pi over 3. Now we get to 5 pi over 6, can't do anything there. 6 pi over 6, 6 and 6 make 1, so that's just pi. 7 pi over 6, nothing we can do. 8 pi over 6, that's going to be a 4 pi over 3. 9 pi over 6, 9 and 6 have a 3 in common, so that's going to be 3 pi over 2. And 10 pi over 6, 10 and 6 both have a 2 in common, so that's going to be 5 pi over 3. And 11 pi over 6, there's nothing we can do with that one. So we get our 30-degree sections, which there are 12 of them around the circle, are counting by pi's over 6. So pi over 6, 2 pi over 6, 3 pi over 6, so on and so forth as we get around the circle. Now in blue, let's look at the 45s. So 45s are going to split the 90-degree sections right in half. So I have one section here. So this arc right here to 45 degrees, I'm going to figure out how many radians is this arc going to be. And then to 90 to there. So there's 3 sections. To get halfway around my circle, I've counted 4 45-degree sections. Count another section, that's 5 sections, 6 sections, 7 sections. There's 8 total sections. So if I look at my full circle, remember, was 2 pi, and there's 8 total 45-degree sections. I'm going to take 2 pi, divide that up by 8. I kind of think of it as like pizza. slice it into 8 slices. We're going to divide that up by 8. That's going to leave us with pi over 4. So that means that this section from here to here, that represents pi over 4 arc length of the whole circle. So that's going to be my first section here is going to be pi over 4. And then at the 90-degree spot, that's 1 pi over 4. This is going to be 2 pi over 4, which just thinking 2 pi over 4, 2 over 4 is still 1/2. So that's still pi over 2. This right here is going to be 3 pi over 4. Down here, 4 pi over 4, just like the 6 over 6, 4 over 4 would simplify just to pi. 5 pi over 4 is going to be right here. 6 pi over 4, 6 over 4 is going to simplify to 3 over 2, just like we have from the 30, 60, 90s that we counted. And finally, we're going to get to 7 pi over 4. So there's going to be our radian measures for our 45s. So when we're counting our 30, 60, 90s, we can count by pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6. When you're counting your 45, 90s, you're counting by pi over 4 radians. So our radians are just a different way to look at the degree measure, or the angle measure, excuse me. So we have degrees that we're more familiar with. Now we also have these radians. Okay.